Section 3.5 is working with sets. I can write sets and identify subsets, and I can find the complement of a set. Big ideas here. Sets are the basis of mathematical language. Sets are written in different ways, including roster form and set builder notation. The elements not in a given set are the complement of a set. Smaller sets of elements can be formed from a larger set. So a set is a collection of distinct elements, like people in our class, for example. A subset contains elements from a set. An example would be freshmen or people wearing red. Okay, so from the people in our class, a smaller group. Roster form is one way of writing sets. In roster form, we list each element of a set within curly brackets or braces. Set builder notation is another way to write sets. It describes the properties an element has to have in order to be included in a set. In example 1, we're going to write T is a set of natural numbers that are less than 6 in roster form. So capital letters are how we label sets. So capital T means set T is. We use curly brackets to show it's a set. We want natural numbers less than 6. Natural numbers start at 1. They're the numbers that we naturally start counting with when we're little kids. 1, 2, 3, 4, and 5. I stop there because I want less than 6. So those are my only options. And in roster form, we just list out all of our options. In set builder notation, our set T is curly brackets, any number. So we pick a variable, any number, as long as we always have to have that x such that. Here, we're restricting it to the set of natural numbers. So we say x is a natural number, comma, because we have another restriction. It's less than 6. So we say that number, our variable, is less than 6. And curly bracket to show it ends. So again, in roster form, we list out all of our options. In set builder notation, we say the things it has to have in order to be included. So it has to be both a natural number and it has to be less than 6. So again, this part you always have in set builder notation. And then in the middle, we always have any restrictions or anything that describes our situation. Now, feel free to pause here and give this a try if you'd like. How do we write n is a set of even natural numbers that are less than or equal to 12 in roster form and in set builder notation? So in roster form first, n, capital letter for my set, equals curly brackets to show it's a set. Roster form, we list them out. So even natural numbers, less than or equal to 12. So we need even natural, less than or equal to 12. So natural numbers start at 1, that's not even. 2 is, 3 is not, 4 is, 5 is not, 6 is, 7 is not, 8 is, 9 is not, 10 is, 11 is not, 12 is, and we stop there because we want it less than or equal to 12. Curly bracket to show that it ends. That's roster form. In set builder notation, we say n is, just like we did before, but remember we always start off with any number such that that number is an even natural number. Okay, that's one of my restrictions, is that it's an even natural number. My second restriction is that it's less than or equal to 12. So comma means like we're continuing on. That number is less than or equal to 12. And again, curly brackets to show that we finished our set. So one more time, roster form, we list them out just like on a basketball roster. 2, 4, 6, 8, 10, 12. In set builder notation, we always have to have that part. And then we list anything in the middle that are the characteristics of our values. Well, they have to be even natural numbers, so we have to say x is an even natural number, and they have to be less than or equal to 12. So I have to say those numbers that are less than or equal to 12. Example 2 here says, in set builder notation, how do we write the solutions of this inequality? Well, before we can write the solutions, we have to solve it. So we're going to solve it the same way we have with inequalities. So right now I'm going to get rid of any adding or subtracting first. And then I get rid of any multiplying or dividing. X is being multiplied by -5, so I divide by -5. And again, anytime I change from positive to negative or negative to positive by multiplication, anytime I multiply or divide by a negative like we did here, I have to flip my inequality. So it becomes x greater than or equal to -2. Now I have my solutions. We want to write them in set builder notation. So remember, in set builder notation, it's curly bracket, any number as long as, here, x greater than or equal to -2 are my only restrictions. It doesn't tell us it has to be a natural number or an integer or anything like that. It can be literally any real number greater than or equal to -2. So in set builder notation, that is my solutions. Now feel free to pause here and give this a try if you'd like. First thing I'm going to do again is to solve for my variable. We're going to write our solutions in set builder notation. So the first thing I do is get rid of a +9 by subtracting, because 9 minus 9 is how I get to 0. Don't forget to take your sign with your number. N is being multiplied by -4, so I'm going to divide to get rid of it. And anytime that we multiply or divide by a negative number, we have got to flip our inequality. So instead of being greater than, now it's less than. To put this in set builder notation, I have no other restrictions, nothing telling me it has to be just an integer or a natural number or even or anything like that. So I say n such that n is less than -3. Keep in mind my variables have to match here, so since I had an n, I have to use n here. Any number n such that n is less than -3. And curly brackets show us it's a set. So my solutions in set builder notation are there. We know that a set A is a subset of set B if every element in A is also in B. We can write this relationship like this. This right here means that A is a subset of B. This symbol tells us it's a subset. Okay, so a set A is a subset of set B if every element in A is also in B. So if set B is the alphabet and set A is just the vowels, that's a subset because A, E, I, O, and U are included in the entire alphabet. Okay, so every element in A, E, I, O, U, is included in B, the entire alphabet, so A is a subset. The empty set or null set is a set that contains no elements. The empty set is a subset of every set. So if we were talking about B being the set of alphabet and a subset being any number that's in there, that would be an empty set. There's nothing in both of those. Okay, nothing in A that's also in B. So our set would be empty. The empty set, we can use one of two symbols to represent. We can either use our no solution symbol, null set, or we can just use empty brackets showing, hey, there's nothing in this set. So here we want to know what are all the subsets of 3, 4, 5 as our set. So here's a quick way to know how many subsets we're going to need. We take 2, count how many elements are in our set. Here I have 3. So I take 2 to the third power and I get 8. I'm going to have 8 subsets. So remember that our empty set or our no solution, either way, however you want to write that, is a subset of every set. So here if I wanted all the numbers greater than 10, there aren't any in 3, 4, 5. So I'd have nothing in my brackets. We could have a set of just a 3. if I wanted multiples of 3. If I wanted just numbers that are multiples of 4, we could have a set that's 4s. Just numbers that are multiples of 5, I'd have just a 5. Okay, now I could have a set that has both 3 and 4 in it, if I wanted numbers less than 5. I could have a set that has both 3 and 5 in it, if I wanted just odd numbers, for example. I could also have a set that has 4 and 5 in it, if I wanted just numbers greater than 3. And I could have a set that has all 3 of these numbers in it, if I wanted a set of natural numbers from here, for example. So there are my 8 subsets that I said we needed. I have 1, 2, 3, 4, 5, 6, 7, and 8. It's all the possible options. Keep in mind, 3, 4, and 4, 3 are the same subset. Okay, just writing them in a different order doesn't change it. It's still the same elements, still the same pieces. Just looks different, but still means the same thing. So again, our subsets are all the different ways that we can write just a part of our set. And the whole thing is included as well. That could be a subset. If my set was 3, 4, 5 and I wanted a subset to be all the natural numbers, I would include all of those in that. If I wanted all of the negative numbers, okay, I'd have none, for example. So those are going to be the 2 most common ones that people forget. Don't forget them. Now, feel free to pause here and give this a try if you'd like. What are the subsets of the set P equals the set of A and B? Well, to figure out how many subsets we have, we take 2. I have 2 elements, so 2 squared gives me 4. I'm going to have a total of 4 subsets. So we know that one of them is always empty set or null set, which is our no solution symbol or just empty brackets. Okay, so that's 1. I could have a set that just has an A in it. I could have a set that just has a B in it. Or I could have a set that's A and B. Those are my 4 sets and all of my options. Now, feel free to pause here and give this a try if you'd like. I take 2 3 elements, so to the 3rd power means I'm going to have 8 total subsets. We always start off with the empty set. Whichever way you want to write it, we just need one or the other of those. I could have a set that just has an A in it. I could have a set that just has a B in it. I could have a set that just has a C in it. I could have A and B. I could have A and C, or I could have B and C. I also could have the set with all of them in it, A, B, C. So another way to think about this, guys, those are my 8 that I need. We start off with our empty set. Then I add an A to it, so I rewrite it with an A in it. Then I take both of those, rewrite them, and add my next letter to both of them, a B. Now, I take all of those and rewrite them with my 3rd thing in it. So C, 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 C. This gives me the same 8 sets, but it's a way to remember all of them without missing any. So no solution, A, B, C, AB, AC, BC, and all of them. So either way, I have my 8 that I need. And it doesn't matter how you come up with them as long as you come up with them. So again, I know I need 8 because I have always 2 raised to the 3 elements, or however many elements we have, gives me 8. So I'm going to need 8 subsets. The most common ones people are going to miss are the empty and the full. So nothing in it or everything in it. And I will stop here and continue in another video.